In the war rooms of Berlin, the most dangerous sentences were not shouted. They were typed. Not on elegant stationery, not in tidy handwriting, but on clattering teleprinters that hammered decisions into paper strips. Orders about armies, rail schedules, oil allocations, and the kind of small logistical truths that decide whether a front line holds or collapses. Hitler's headquarters and the German High Command believed those messages moved through the air like sealed steel. They had a new cipher system for the highest level traffic, a machine so complex that even experienced cryptanalysts would stare at the intercepted signals and see only noise. The British gave the system a code name, Tunny. They did not start by knowing what Tunny was. They started by knowing what it felt like, a stream of 5-bit teleprinter code that looked structured, almost human, and then suddenly broke into chaotic patterns like footsteps disappearing in snow. Somewhere behind that stream was a machine, Lorenz, spinning wheels that added layers of randomness so thoroughly that conventional techniques ran into a wall. At Bletchley Park, walls were invitations, but Tunny was different. Enigma was a lock you could pick if you learned the lock's habits. Tunny was a storm, huge, shifting, and full of hidden gears. Then the first miracle happened, and it was not a machine. It was a mistake. In 1941, a German operator under pressure and tired hands sent the same long message twice, nearly identical, using the same wheel settings. It was a blunder of discipline, the kind armies punish quietly. But for the men listening across the channel, it was like watching a door swing open for 1 second. From that slip, a young mathematician named Bill Tutt began to do something that sounded impossible. Reconstruct the Lorenz machine's structure without seeing it, not by capturing one, not by bribing an engineer, but by studying patterns in the ciphertext as if the machine's shadow had been pressed onto paper. He teased out the idea of wheels, 12 of them, working in layers. He inferred how they stepped. He inferred which wheels controlled which patterns. He turned noise into a schematic. By the time Tata was done, Bletchley had something rarer than a key. It had an understanding of the enemy's mechanism. But understanding is not the same as speed. Even with a model of Lorenz, the job was brutal. To read Tunny, you had to find wheel settings, starting positions, and that meant searching through enormous possibilities. The early method used a machine called Heath Robinson, 2 paper tapes running fast, one with the intercepted message, one with a guessed wheel pattern synchronized at high speed. It was clever, and it was maddening. Paper tapes stretched, they tore, they slipped out of alignment by fractions that ruined hours of work. The machine was fighting physics, and physics was winning. In 1943, the pressure on Bletchley intensified. The Allies were planning invasions, deception operations, massive coordinated movements. They did not need intelligence next month. They needed it tonight, and again tomorrow, and again the day after. A decrypted message about German reserves or rail bottlenecks was only valuable if it arrived while decisions could still change. That is when the second miracle arrived, and it sounded like heresy. A builder from the General Post Office research station, an engineer named Tommy Flowers, looked at Heath Robinson and saw not a cryptographic problem, but an engineering failure. He believed the tape synchronization was a dead end. If the heart of the problem was counting patterns fast and reliably, why not count them electronically? Why not replace the fragile dance of paper with valves, pulses, and circuits? In 1943, that suggestion sounded reckless. Vacuum tubes, valves, were seen as delicate, unreliable components. A few could be trusted in radios. Hundreds were considered risky. Thousands were considered madness. Bletchley's culture respected cleverness, but it was cautious about building a colossus of electronics that might collapse into smoke. Flowers had a different worldview. He worked with telephone switching systems, machines that had to run continuously, day and night, with high reliability. He knew something counterintuitive. Valves fail most often when they're turned on and off. Keep them warm, keep them stable, and they can run for long periods. Where others saw fragility, he saw endurance, if engineered correctly. He pitched an idea that sounded like science fiction for a wartime hut in Buckinghamshire, a programmable electronic machine that could read a paper tape at high speed, generate wheel patterns electronically, compare them to the ciphertext, and count statistical correlations, all fast enough to keep up with war. The idea landed in the right hands at the right moment. Max Newman, who ran the section responsible for mechanizing Tunny work, the Newmanry, understood that the bottleneck was speed. He also understood the rare value of an engineer who could turn theory into hardware. Flowers went back to Dollis Hill, his post office lab, and started building. He did not build as a philosopher builds, with perfect conditions and unlimited time. He built under bombing raids and material shortages. He built with the knowledge that if he failed, the war would not pause politely. He built a machine that would need to read punched tape at unprecedented speeds, using photoelectric cells to see the holes as light pulses. He built circuits that could be rewired, not with software in the modern sense, but with plug boards and switches, so that the logical tests could change as cryptanalysts refined their methods. He built a machine with the arrogance of a man who understood the stakes and the humility of a man who knew metal and heat do not care about hope. This machine would become Colossus, and Colossus was not meant to break Lorenz in the romantic sense of finding a single permanent key. Lorenz was not like that. It used daily settings. It used wheel patterns. The problem was to recover the wheel start positions, especially the chi wheels, so that the message could be stripped of its mask. Colossus would accelerate a statistical method called delta analysis, comparing changes in ciphertext against hypothesized wheel behavior, counting how often certain patterns aligned more than pure chance would allow. In plain terms, it would listen to the enemy's randomness and measure where the randomness was not random. That is what broke Hitler's secret messages. Not a dramatic theft, but an industrial approach to probability, executed at electronic speed. By late 1943, Colossus was taking shape as a mass of racks, wires, valves, and control panels, an unholy mixture of telephone engineering and wartime urgency. It was loud, hot, and alive with the hum of electricity. It did not look like a weapon, but it was designed to do something that weapons could not: deliver certainty at the speed of command. The war's quiet truth is that an army can endure hunger longer than it can endure confusion. When you know where the enemy is moving, you can let him move into emptiness. When you know what he believes, you can feed him lies. Colossus was being built to do exactly that. And when it arrived at Bletchley Park, it would not only accelerate decryption, it would change the tempo of intelligence itself, turning Tunny from an occasional miracle into a reliable stream. The third miracle was coming. Not a German mistake, not a mathematician's insight, but an engineer's refusal to accept that the future had to be made of paper. Tommy Flowers did not arrive at Bletchley Park like a prophet. He arrived like a man who had spent years arguing with machines that refused to behave. He was not from the university world that produced so many of Bletchley's theorists. His confidence came from switch rooms, relay banks, and the stubborn reality of telephone networks, systems that either worked or forced you to admit you were wrong. In that world, elegance was optional. Reliability was everything. That difference mattered because the problem with Tunny was no longer intellectual. It was industrial. Bletchley had already done the impossible once when Tut reconstructed the Lorenz machine's logic from pure ciphertext. But reconstruction was only the beginning. If you could not set the machine fast enough, if you could not test wheel starts before the message went cold, then intelligence became a trophy rather than a tool. Heath Robinson had shown the shape of a solution and also its ceiling. 2 high-speed tapes had to run in perfect sync. The tapes did not cooperate. They stretched with heat. They slipped over rollers. A tiny tear at the edge would become a catastrophic wobble. For cryptanalysts waiting for results, it felt like watching a racehorse trip over its own reins. Flowers stared at that frustration and made a decision that sounded insane. He would remove the second tape. Instead of chasing synchronization with paper, he would generate the wheel patterns electronically, stable, adjustable, relentless. The intercepted message tape would still run because the enemy had already punched the information into it. But the guess tape, the fragile partner, would be replaced by a machine that could think in pulses. The idea moved across Bletchley like a controversial rumor. Many people respected Flowers. Many people also believed he was walking toward a fire with a bucket of gasoline. Electronics at that scale didn't have a long reputation for reliability. A few valves were normal. Hundreds were risky. Thousands sounded like a breakdown waiting to happen. The sort of machine that would spend more time being repaired than producing results. Flowers heard the objections and treated them like he treated noise on a phone line. Something to be measured, not feared. Valves failed most when you cycled them. Heat them, cool them, heat them again, and the stress cracks the internal structures. Keep them warm and stable, and they could run for astonishing periods. Telephone exchanges had already taught him that. He believed he could build a machine that would run not for minutes, but for weeks, if he designed it like an exchange rather than a laboratory toy. The second obstacle was not technology, it was authority. Wartime Britain was a world of committees, procurement forms, and cautious budgets. Flowers could not simply demand thousands of valves and endless copper wire. He needed support, and support in war required a kind of persuasion that felt close to espionage itself. You had to convince skeptical gatekeepers that your impossible plan was less dangerous than doing nothing. Max Newman became the critical ally. Newman's section lived on the edge of urgency. They were not building machines for beauty. They were building machines to crush time. Newman understood that if Flowers was right, Tunny decryption could become routine, not miraculous. So Flowers began assembling his Colossus at Dollis Hill, away from Bletchley's huts, in the calmer environment of post office engineering culture. But calm is relative. London was still living under threat. Materials were rationed, skilled labor was stretched, and secrecy wrapped the project in a tight skin. Even the name Colossus carried a quiet defiance, an acknowledgement that the machine would be enormous and that it would dare the era to keep up. He chose photoelectric reading because it was faster than mechanical contact. The punched tape would pass through a reader where light beams would be interrupted by holes, turning physical absence into electrical presence. It was elegant in its own blunt way. The tape becomes a strobing pattern, and the machine becomes a listener that never blinks. Inside the racks, valves served as switches, amplifiers, and logic gates. Modern audiences imagine computers as silent. Colossus was not silent. It hummed, clicked, and exhaled heat. It demanded ventilation, discipline, and the kind of maintenance that feels like caring for an engine rather than using a device. Flowers built in programmability too, though the word meant something different then. Not lines of code on a screen, but wiring changes, plug boards, switch settings. It was a machine that could be reconfigured as the mathematicians refined their tests, as the enemy altered habits, as new statistical tricks were invented. In war, flexibility is survival. And then there was the human factor. Trust in a machine. Bletchley was already a place where human brilliance met mechanical speed. But Colossus asked people to hand over judgment to electronics in a way that felt almost unnatural. The machine would not read German like a linguist. It would count. It would compare. It would find correlations that hinted at the correct wheel starts, then present those results so that humans could complete the decryption pipeline. It was not replacing people. It was compressing time. By late 1943, the first Colossus was approaching completion. Its panels stood like a wall of purposeful complexity. The wiring behind them was dense, disciplined, and strangely beautiful in the way a ship's engine room is beautiful, not because it tries to impress you, but because it is built to endure. Then the war set its own deadline. Early 1944 was looming. The Allies were preparing the most ambitious deception and invasion effort of the war. Information about German high command communications, strategic traffic, not battlefield chatter, would be priceless. If Colossus could make Tunny workable at speed, it could reveal German assessments, redeployment plans, anxieties, and assumptions. It could show where the enemy expected the blow, and therefore where the enemy might be fooled. That is what broke Hitler's secret messages in practical terms. Not because Colossus was magic, but because it made the enemy's secrecy expensive to maintain. The Germans could change settings daily, but they could not change the laws of probability. And once Britain could hunt wheel starts quickly, Lorenz became less like a fortress and more like a locked door in a corridor that analysts walk through every morning. When Flowers finally brought Colossus to Bletchley, he was delivering more than a machine. He was delivering a new rhythm of war, intelligence fast enough to shape operations, not just explain them afterward. But Colossus still had to prove itself. A machine can be brilliant on paper and useless in practice. It can fail under heat. It can drift. It can produce false confidence. The first time it ran at Bletchley, it was not merely a technical test. It was a test of belief. Because if the Colossus failed, Tunny would return to being a ghost, visible only in rare flashes of luck. And if it succeeded, it would turn Hitler's highest-level traffic into something Britain could watch with steady, terrifying clarity. The next part of the story is the moment the racks come alive. And the moment Bletchley realizes it is no longer racing time, it is hunting it. The first time Colossus ran at Bletchley Park, it did not feel like a triumph. It felt like a risk made audible. The machine arrived as a set of racks and panels that seemed too large for the huts that held them. It had the posture of something industrial, telephone exchange thinking forced into a wartime shed. Cables descended like roots. Valves waited behind panels, warm and patient, ready to prove or betray the engineer who had insisted they could be trusted. The people who gathered were not there for spectacle. They were there because the war had trained them to respect moments that looked ordinary. A strip of punched tape could contain the fate of a division. A slight change in German phrasing could mean a redeployment. A statistical spike on a counter could mean that wheel starts were close enough for linguists and clerks to turn an unreadable stream into German sentences that mattered. Flowers stood near the machine with the quiet tension of a builder watching someone else drive his vehicle for the first time. The cryptanalysts didn't share his engineering faith. They shared his urgency. They wanted results, and they had learned to distrust promises. The tape went into the reader. The lamp came on. A thin, relentless motion began. Holes passing light, light becoming pulses, pulses becoming counts. This was the heart of Flowers' gamble. Turn physical uncertainty into electronic regularity. The tape would not be argued with. It would simply run, and the machine would keep up. At first, it was easy to miss what was happening because Colossus did not display the enemy's words. It displayed a more subtle kind of truth. Numbers. Counters clicked. Lamps flickered. A rhythm formed that had nothing to do with German and everything to do with probability. Colossus was testing hypotheses, wheel patterns, offsets, correlations, faster than human hands could ever manage. It was searching for the slight, stubborn bias that appears when you subtract a correct wheel stream from a message. The place where randomness stops behaving like randomness. In practice, it meant something like this. If you guessed the wrong starting positions, the statistics stayed flat, indifferent. If you guessed close to the right positions, the counts began to lean. Not dramatically. War rarely provides fireworks, but enough that trained analysts could feel it. Enough that they could say, "Run that again," or "Shift that wheel one step," or "This is not noise." Colossus did not deliver certainty as a single moment. It delivered it as a trend. And that was the change. Bletchley's earlier methods often relied on rare breakthroughs, a captured book, a sloppy operator, a lucky crib. Colossus offered a different kind of power. Repeatable, mechanical, scalable. It could be fed the day's intercepted traffic, and, with the right setup, pull out likely wheel start positions at a speed that made the rest of the decryption pipeline feasible. That pipeline mattered. Once Colossus narrowed the Chi wheel starts, the message could be stripped of much of its masking. Then other methods, still partly manual, partly machine-assisted, could recover further details. In the end, the plaintext did not appear like magic. It was assembled piece by piece in rooms where people spoke in shorthand and slept in chairs. But speed changes everything. A message that once took days to crack could now be approached within hours, sometimes faster. And the content of Tunny traffic was not tactical chatter. It was strategic nervous system traffic. Communications between Hitler's headquarters and his field commanders between Berlin and armies that needed fuel and rail cars and replacements that could not be conjured. Colossus made those conversations legible at the tempo of war. What followed was not a single "we broke it" moment. It was a shift in routine. Intercepts arrived, machine runs were configured, counters produced patterns. Analysts handed likely starts to the next stage, clerks typed, translators worked, officers read, decisions moved. Somewhere in that flow, the Germans continued to believe they were speaking behind an unbreakable curtain. That belief was the real prize. Because once you know what the enemy believes about you, you can shape his belief like a craftsman shapes metal. You can reinforce his assumptions until they harden into mistakes. You can exploit delays in his logistics. You can watch him move reserves to the wrong place, then strike the place he left thin. In early 1944, as Allied planning gathered mass, Tunny intelligence became part of the background pressure that helped Bletchley and British command judge German intentions and capacity. Colossus was not the only source of truth, and it was not a single switch that turned the war. But it changed the quality of the conversation inside Allied headquarters. It made high-level German thinking less mysterious and more measurable. A deception plan is only as good as the enemy's willingness to believe it. Logistics is only as strong as the enemy's ability to predict where you will hit. With Tunny flowing, the Allies could sense when German command began to tilt, when they started to worry about certain sectors, when they argued about shortages, when they anticipated landings, when they misread the signals. Colossus also did something psychologically important inside Bletchley. It made confidence possible. The men and women who worked the Tunny problem were used to uncertainty. They lived in a world of partial intercepts, damaged tapes, and urgent commanders asking questions no one could answer with complete certainty. A machine that delivered statistical confidence, repeatable, testable, did more than save time. It calmed panic. It allowed planning. It made the work feel less like gambling and more like engineering. And as soon as the first Colossus proved it could run, the next decision arrived with the cruelty of wartime logic: build more. Colossus was not a one-off marvel. It became a production effort under secrecy. Additional machines were constructed, refined, and installed. They were numbered. They evolved. Their capabilities expanded. Their tape speeds increased. Their reliability improved as Flowers' instincts were validated in practice. For the people on the inside, a strange inversion happened. The machine that had once seemed too risky became the safest part of the process. The human side stayed fragile. Fatigue, mistakes, the pressure of knowing that a late report could mean lives lost. But the electronics kept running, warm and steady, counting relentlessly through the night. If Enigma was the romantic story the public eventually learned to love, Colossus was the more unsettling truth. A machine built not to be admired, but to operate, quietly, repeatedly, without applause, while history turned. And somewhere behind the numbers, a deeper revelation was forming. It was not just that Britain had built a machine to break a cipher. It was that modern war had created a new kind of weapon: computation. The next part is where that weapon meets the largest stage of the war: the invasion, the deception, the critical months when German command had to choose where to place its strength and where its assumptions would be punished. By spring 1944, Britain's war was no longer defined by survival. It was defined by timing. The invasion that would become the hinge of Europe, Operation Overlord, was being built from rail schedules, fuel dumps, shipping tables, and weather forecasts. It was being built from the mundane mathematics of moving men and metal across water and then across hedgerows. And it was being protected by something even more fragile than steel. A story the Germans needed to believe. Because if Berlin could place its reserves correctly, if it could read Allied intent early enough, then beaches would become slaughterhouses, and the entire campaign could stall before it began. The Allies did not just need tanks and landing craft. They needed the enemy to misread the map. That was why deception became doctrine. Fortitude, the umbrella deception plan, was not one trick. It was a long performance. Fake armies, fake radio traffic, double agents feeding carefully measured lies, inflatable equipment photographed at the right distance. The goal was not to fool a private. The goal was to guide Hitler's mind, and the minds beneath him, toward a conclusion that felt like their own. But deception has a harsh rule. You cannot simply invent a lie. You must continuously check whether the lie is working. That is where Tunny mattered. The Lorenz traffic carried the high-level nervous system chatter of German command, assessments, arguments, anxieties, redeployment talk. It did not always announce decisions in clean sentences. Sometimes it was a mood. Sometimes it was a fixation. Sometimes it was the absence of movement where movement should have been. With Colossus running, Bletchley could sense those moods faster than before. It could watch German command harden around a belief. It could watch them hesitate. It could watch them argue about where the blow would fall and what they were willing to sacrifice to protect it. In the months before D-Day, the most valuable intelligence was not always a precise location. It was insight into confidence. If German command remained convinced the main invasion would strike the Pas de Calais, then they would hold key panzer divisions back, waiting for the real landings after Normandy was revealed as a feint. That delay would be oxygen for the Allied beachhead. If, however, German commanders began to doubt, if they started shifting reserves toward Normandy quickly, then the invasion would face a different kind of fight, one measured in hours. This is the uncomfortable power of reading secret messages. It does not give you omniscience. It gives you tempo. Colossus sharpened that tempo. It made Tunny output less like a rare signal and more like a steady feed. Analysts could push intercepts through faster, identify likely wheel starts sooner, and hand off decryptable material while it still mattered. That meant the intelligence apparatus could react not to German actions after they occurred, but to German thinking while it was forming. War is full of decisions made inside rooms. The battlefield is only where those decisions take shape. In Germany's rooms, there were patterns of pride and caution. Hitler trusted his instincts even when his logistics screamed otherwise. He believed in the dramatic counterstroke, the sudden reversal. Many of his generals understood the reality: fuel shortages, exhausted formations, rail lines strained by Allied bombing. But they still had to argue within a system where the leader's belief often outweighed the evidence. In such a system, deception was not merely helpful, it was lethal. When Allied deception convinced German leaders that a larger force threatened Calais, it did not simply create confusion, it exploited the enemy's preference for the logical option. Calais was closer. Calais had better ports. Calais was what a rational planner would choose. Therefore, Many German planners saw Calais not as a guess, but as inevitability. Bletchley's role was to measure whether that inevitability was taking hold. Colossus helped provide that measurement, not by announcing "they believe it" in a neat headline, but by enabling more frequent glimpses into high-level communications, glimpses that, when accumulated, revealed a direction of thought. It was a statistical advantage turned into strategic confidence, yet the story was never clean. Tunny was only one channel among many. German decisions were scattered across personalities and command levels, across competing agencies, across a leadership style that often created paralysis through interference. Even perfect intelligence does not guarantee perfect outcomes. It simply removes excuses. And the closer June approached, the more Bletchley understood a deeper truth. The enemy's secrecy was still working, just not in the way the Germans believed. Lorenz was still complex. Its wheel settings still changed. But the presence of Colossus meant Britain could treat each day's complexity as a problem of production, not mystery. Instead of praying for another operator blunder, they built a workflow. They scaled the work. They improved the machine's speed and reliability. They trained operators who could run it through the night without letting fatigue turn precision into guesswork. The result was an intelligence system that felt less like a spy story and more like a factory. Intercept in, machine run, statistical result, decrypt, translate, summarize, deliver. In 1944, that assembly line of understanding became part of the environment in which Overlord was planned and protected. It did not replace courage on the beaches. It did not make the sky less lethal, but it helped ensure that German command, trapped inside its own assumptions, would not commit its full strength at the moment it mattered most. And when the landings came, the German reaction was the real test of deception. Would reserves surge immediately? Would the high command pivot, admit the truth, and throw everything at Normandy? Or would they hold back, waiting for the real blow because the lie had become stronger than the evidence? That hesitation, measured in hours, then in days, was a form of victory in itself, because in invasion warfare, time is territory. Every hour a panzer division stays parked for the wrong reason is an hour the beachhead hardens. Every day German command argues internally is a day Allied engineers build roads, stock ammunition, and turn sand into supply lines. Colossus, in the background, did not fire a shot. It did something colder. It reduced uncertainty. It gave Allied leadership a clearer picture of how the enemy's mind was bending under pressure, how belief was being shaped, and how fear and pride were competing in German rooms. It is tempting to imagine that the machine won the war in a single heroic act. That is not how it worked. Colossus did not win battles. It made battles more survivable by narrowing the unknowns. It made deception measurable. It made planning less blind. And in a war where blind planning meant mass death, that mattered more than romance. By mid-1944, the Colossus had become not an experiment, but a quiet partner in the largest gamble of the century. And as the war moved from beaches to hedgerows, and from hedgerows to broken cities, another truth began to surface. The machine's influence would not end with Germany's defeat. Because once a nation learns that computation can break secrecy, no secret ever feels the same again. When Germany began to collapse, the war did not instantly become quiet at Bletchley Park. For the people inside the huts, victory had a strange shape. It looked like more work. The messages kept coming. The machine kept running. The staff kept living in the same rhythms of night shifts, paper cuts, tea mugs gone cold, and the constant discipline of secrecy. Even in triumph, they could not celebrate out loud because the real achievement was still invisible. The enemy could not be allowed to know what had been done to him. That secrecy was not vanity. It was strategy. Colossus had proven something that could not be unproven, that a determined nation could build a machine to turn complex ciphers into solvable routines. That knowledge was a weapon, and weapons do not retire politely. The world that followed the war would not be safer, only different. Alliances would shift. New threats would appear. Intelligence would remain a currency. If Britain revealed too much about how Tunny was broken, it would not just rewrite the past. It would weaken the future. So the end of Colossus was planned with the same cold competence as its birth. Panels were removed. Documentation was limited. People were told, in blunt terms, to forget. Some machines were dismantled. Others were destroyed. Even the language of the project was buried. For decades, the public story of wartime codebreaking leaned heavily on enigma, partly because it was dramatic, partly because it could be told without revealing everything. Colossus remained a rumor behind a locked door. That is the cruel irony at the center of this story. The machine that helped the Allies read Hitler's highest-level communications was so effective that it had to vanish. For Tommy Flowers, this disappearance carried a personal cost. He had built something extraordinary, but in the post-war world, there were no medals, no public praise, no obvious career leap that matched the scale of the achievement. His colleagues in engineering understood that he had done something rare, but the nation that benefited most could not openly acknowledge it. In the way war often is, the reward was survival and silence. Yet the machine's influence leaked into history anyway, because ideas cannot be dismantled as easily as racks. Colossus proved that electronics could be reliable at scale. It proved that logic could be mechanized with speed and flexibility. It proved that statistical thinking, probability measured and exploited, could become operational power. The machine was built to fight a cipher, but it ended up pointing at the shape of the future, computation as a tool of statecraft. And that future came fast. After the war, the world entered an era where information moved as a strategic resource, where communication networks became targets, and where the ability to process data quickly, accurately, became a form of national strength. Colossus was not the only step into that world, but it was one of the clearest and one of the earliest examples of computing built with a mission that demanded results. It also left a quieter legacy inside the people who worked with it. They learned that secrecy is never absolute, only expensive. They learned that unbreakable is a psychological claim, not a mathematical guarantee. They learned that the enemy's confidence can be exploited, not by brute force alone, but by understanding the mechanisms behind that confidence. That understanding shaped more than code-breaking. It shaped how modern intelligence thinks about war. Because war is not only fought with tanks and bombs, it is fought with assumptions. The Germans assumed Lorenz traffic was safe because it was complex, because it was not widely distributed, because it belonged to the highest levels. They assumed that even if the British intercepted it, decoding would be too slow to matter. They assumed they could change wheel settings and remain ahead. What they did not account for was a builder's mindset, someone who treats complexity as something you can engineer around. Flowers did not solve Lorenz in the way a puzzle is solved. He helped transform the problem from art into process. He helped turn rare breakthroughs into repeatable output. He helped make the intelligence machine at Bletchley Park more like an engine. Feed it, run it, maintain it, and it will deliver. That shift changes the moral landscape of intelligence. When secrets can be read, deception becomes easier and more dangerous. When messages can be processed quickly, decisions can be made with confidence, and confidence can be used well or abused. Colossus gave the Allies leverage, but it also hinted at an uncomfortable future, a world where the power to compute becomes the power to see. And seeing is never neutral. Still, in the strict boundaries of this wartime story, the effect is clear. Colossus helped Britain and its allies interpret German high command communications with a speed that mattered. It helped measure enemy belief and hesitation. It helped confirm when deception took hold. It helped reduce uncertainty during the most delicate planning of the war. It did not guarantee success, and it did not replace sacrifice. But it changed the conditions under which sacrifice was demanded. In the end, the machine's true drama was not its noise and heat. It was the contrast at its core. A war defined by chaos, answered by calculation. A regime obsessed with control, undone by its own reliance on communication. A secret message system designed to be unreadable, broken not by luck alone, but by the steady, engineered refusal to accept limits. That is why the story resonates beyond code breaking. Because it is not only about what was built, it is about what was believed to be impossible, and what happened when a builder decided that impossible was simply a timeline problem. Somewhere in a dim hut, long after midnight, Colossus once stood humming as punched tape flashed through light, turning absence into pulses, pulses into counts, and counts into clarity. Outside, the war was loud and brutal. Inside, the most decisive weapon was quiet. Not a gun. A machine that could make sense of a world trying to drown itself in noise. And when the machine finally disappeared, the lesson remained. In modern war, the side that understands faster does not just survive. It shapes what the enemy believes and what the enemy becomes.